Yeah, good afternoon. Here is a concept map for Calculus AB Free Response Question 2008, and it's question number 1. And the disclaimer is this is just a walkthrough of kind of the big ideas, how to do the question. This would not be the final answers that the AP graders are looking for a final answer on the exam. This is just getting you going in the right direction. So let's go ahead and look at question 1. So question 1, it says let R be the region bound by the graphs of, and they give you two functions, a sine wave, so it looks like this one is going to be the sine wave, that looks like a sine wave, and then the other one is going to be the cubic function. If you're unsure, you can just double check this on a graphing calculator, put these into your calculator. Since you're going to probably need to do that anyways for parts of the problem, so just double check that this is actually the sine equation and this one is actually the cubic function. And when I'm reading these questions, the first thing I think of before I even read the problems is I'm assuming they're probably going to ask me for the area of a region. And we know the area between two curves is the top curve minus the bottom curve. And then they also might ask me about a volume, whether it's a disk method, a washer method, or maybe a cross-sectional area type question. So for part A, it just says find the region R between the two curves. So to find the region between two curves, you're just going to integrate the top curve minus the bottom curve. So big idea, we're going to integrate top curve minus bottom curve from A to B, and you'll need to determine the A to B, so it looks like it's going to go from 0 to 2 in this particular case. So you'll have to find those A and B values. So that's probably pretty much it for part A. Just integrate top curve minus bottom curve. It is calculator active, so you definitely want to get that set up and do it on your calculator to speed things up. You don't want to spend the time doing that by hand. And question B. So question B. It says the horizontal line at y equals -2. So let's find y equals -2. We have a horizontal line here. So there's your horizontal line at y equals -2. So we have a horizontal line at y equals -2. Splits the region R into two parts. So you have the part above it, and you have the part below the y equals 2 line. Write but do not evaluate an integral expression for the area of the part of R that is below the line. So this is another top curve minus bottom curve question, just with a little bit of a twist on it. So we're looking for this. Which one's going to be the top curve? The y equals 2 is going to be the top function. And the bottom function is going to be the portion of the cubic from here to here. So again, you're going to integrate top curve minus bottom curve. From A to B, you're going to need to use your calculator and find those intersection points. So you're going to need to locate these intersection points. So put y equals -2 into your calculator and find the point of intersection between the cubic and y equals -2. So that's going to be your A value. And this one is going to be your B value. And then you just want to set that up with your found A and B values, and then put in the top curve minus bottom curve statement. So it's going to be the top curve is the y equals -2, and the bottom curve is that cubic function. And let's get ready for part C. So part C, It says the region R is the base of a solid. So as soon as I hear this, read this, first thing that comes into mind is it's probably going to be a cross-sectional area. So it's going to be the sum of cross-sectional areas from A to B. But let's keep reading and see if that is the case. So the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume. So this is going to find us the volume. So if you can visualize what they're saying here, as you slide across this base, so R is the base, or the floor of this three-dimensional object, as you slide your cross-sections across the base from left to right, the size of the cross-section is going to keep changing. And they said the shape of the cross-section is going to be a square. So for example, maybe at this point from here to here, your square is going to have side length S. So it's going to go across the shape, it's going to come up off the page, go over and back down, but each side length is going to be as long as that side length right there. Somewhere else in the figure, maybe from here to here, you're going to have a side length S that's this long, and it's going to go across the figure, it's going to come up that tall, over and back down, and you're going to make a cross-sectional square at that point on the figure, and you're going to slide, you're going to sum up all those cross-sectional areas from left to right, from A to B. So from here to here, those are going to be your A to B values. So how do we find our formula for the cross-sectional area? So we know that the length of the square is going to be basically the distance between the top curve minus the bottom curve. So we know our area model for a square is side squared. And how do we represent S in terms of variable x? Well, what's the distance from here to here? It's just the distance between the top curve minus the bottom curve. What's the distance on the other one from here to here? Again, it's just the top curve minus the bottom curve. So S is going to be the top curve minus the bottom curve, and that will find you the length of S. So for your setup, for this setup right here, your volume, you're going to integrate from A to B, so in this case from 0 to 2, of the top curve minus the bottom curve, so that's going to represent your S. But what are we doing to S? We are squaring it, so it's going to be squared, and that's going to be with respect to x, and that would be your setup for that. And for part D, it says region R models the surface area of a small pond at all points in that region R at a distance x from the y-axis. The depth of the water is given by this function h of x is equal to 3 minus x. So basically they're saying that if you pick a point in the pond somewhere and you want to know how deep it is, maybe we pick the point right here. And if we want to know what the depth is right there, then we're going to use this equation to tell us the depth. So at all points in R at a distance x from the y-axis, so whatever your x value is at that point, so that particular x value is going to go into function h, and it's going to tell you how deep it is, or how tall it is. And if you think about how you find the volume of pretty much any shape, the volume of any shape is the base area times the height. So if you had a traditional geometric shape, you're going to have kind of polygons for bases, or circles, or some basic geometric shape. So if you were looking at a rectangular prism, let's look at this. So if we had, you know, a rectangular prism and we wanted to talk about the volume, So what's the volume of this particular shape? It's going to be the base area multiplied by how tall it is. So it's the capital B for base area times the height. If you had a different base for a different shape, so if you had a cylinder, for example, and you had a cylinder and you wanted the volume of a cylinder, what's the capital B going to be? That's going to be your base multiplied by your height. So it's going to be following the same basic formula that it's going to be the base area times the height. So in this case, for a cylinder, how do you find the base area? Pi r squared for a circle times the height. If you had a triangular prism, same idea. It'll be a base area times a height. So let's say we had some sort of triangular prism, and this was your base area times your height. That would get you the volume for a triangular prism. And how do you find the area of a triangle? That would be 1/2 the base of the triangle, different base than the base of the three-dimensional shape, so lowercase b, times the height. Again, a different height than the height of the three-dimensional shape, multiplied by the height of the prism. So big idea is to find the volume of a three-dimensional object. It's going to be the base area times the height. So on this problem, the base area, the capital B, is what r is. So this is your base, and then this is your height at any particular point. So to find the volume, it's going to be the area of r multiplied by the height, which is basically the h of x function. How do you represent the area of r? We found that in part A. So that's going to be integrating the top curve minus the bottom curve. So to find your volume, we're going to go from 0 to 2. And it's going to be pretty much what we did in part A, the top curve minus the bottom curve. So that's going to find the area of the base, r, multiplied by the h function, which is going to be the 3 minus x. And that's going to be your setup, and then you just need to go ahead and evaluate. Again, you'd probably want to do this on the calculator. Get your functions set up in your calculator, get it all typed in, and it is calculator active, so you want to integrate that from 0 to 2. And that should be it for question 1 from the 2008 exam. Again, those are not all final answers. That's just a walkthrough on kind of how to set those up. You definitely want to go through and do it out in detail and make sure you have good final answers and good support work to get full credit on the AP exam.